take a breath. It works. It has always worked. You don't check it. You don't thank it. You just do it. And the air gives back exactly what your body expects. That expectation is very old and very specific. Right now, the air you are breathing is about 420 parts per million carbon dioxide, 21% oxygen, and the world outside averages roughly 15 degrees Celsius. Those three numbers are the dashboard of a habitable planet. In every episode of this series, we watch that dashboard. Today, all three needles move at once, and there is a fourth needle you have never had to think about. We are going back 252 million years, the very end of the Permian. This is the deepest cut in the whole history of animal life. The event geologists simply call the Great Dying. Not the asteroid that took the dinosaurs. That comes 186 million years after this, and by comparison, it is almost gentle. You are arriving in the worst moment to be alive that has ever existed. You are standing on a reef, or what was a reef. For hundreds of millions of years, these shallow tropical seas built vast reef systems, and you are standing on the wreckage of one. The limestone under your feet is bleached bone white, and it crumbles when you shift your weight, like chalk that has been left in acid. The water in front of you is not blue. It is brown and slack and wrong. And the smell reaches you before anything else does. Rotten eggs, sulfur. It is in the water, it is in the haze on the horizon, it is a taste at the back of your throat, and it does not go away. There is no clean lungful to be had here. Turn inland. The land is worse. Skeletons of dead trees stand grey against a hazy sky. No leaves, no green, horizon to horizon. The topsoil is gone, stripped down to bare rock by rain that fell as dilute acid. Whatever lived here recently is not here now. Now look at the dashboard, because it explains the corpse of a world you are standing in. Carbon dioxide has not crept up. It has detonated from a few hundred parts per million to somewhere between 5,000 and 8,000. That is more than 10 times the air your body was built for. And oxygen has gone the other way, sagging towards 16%, thin enough that this thick, hot, poisoned air still leaves you starved. Here's what the CO2 alone does to you. Your body is not really built to detect the lack of oxygen. What it monitors, breath by breath, is carbon dioxide, and it drives your lungs to expel it. Your blood carries that CO2 out of your tissues by dumping it into air that holds less of it. When the outside air is this saturated, that gradient collapses. The gas backs up inside you. Your blood turns acidic, your breathing goes ragged and fast, and within minutes your thoughts start to smear. Confusion first, a pounding headache, and then a dangerous floating calm, the kind that stops you from realizing anything is wrong at all. Peter Brannan, in his account of these extinctions, keeps returning to the tropical oceans, which climate models put at around 40 degrees Celsius here. 10 degrees hotter than a warm sea today. Too hot for most animals to think, to swim, to hold territory. So hot that the tropics became, in the phrase researchers actually use, a dead zone that marine life fled. Confused, slow, overheating, and you have not yet met the thing that actually kills you, that fourth gauge. It is time to label it hydrogen sulfide, H2S. To understand why it is here, follow the carbon. Around 252 million years ago, in what is now Siberia, the crust split open and stayed open for roughly a million years. The eruptions we call the Siberian Traps buried an area the size of a continent in lava. Seth Burgess and colleagues, dating these rocks precisely, showed the extinction pulse lines up with the moment the magma stopped merely erupting and started shouldering its way sideways through the surrounding rock. And that surrounding rock was one of the largest coal and salt basins on Earth. The magma didn't just erupt, it cooked the ground, it baked buried carbon and burned it, releasing carbon dioxide and sulfur on an industrial scale before industry existed. That CO2 warmed and acidified the oceans. Matthew Clarkson and colleagues, reading the boron chemistry locked in these rocks, found direct fingerprints of ocean acidification in the final pulse of the dying. Warm water holds less oxygen. The deep ocean went anoxic, and in an ocean with no oxygen, a different kind of bacteria takes over. They breathe sulfate instead, and they exhale hydrogen sulfide. This is the Euxinia hypothesis, argued most forcefully by Lee Kump. The poison deep water welled up, the H2S saturated the sea, and then it bubbled out into the air. The rotten egg haze on your horizon is the ocean itself exhaling poison. So stand still and count your threats. The carbon dioxide is confusing you. The thin oxygen is slowing you. And the hydrogen sulfide, in high enough concentration, does something faster and more final than either. It slips into your cells and jams the mitochondria, the tiny engines that turn oxygen into usable energy. It blocks the exact machine your body uses to breathe at the level of the cell. Not enough oxygen and no way to use what little there is. 3 poisons, 1 breath. Each one alone would be an emergency. Which of them reaches you first is almost a formality. Look for life anyway. There is very little to find. The reef builders are gone or going. The great Paleozoic communities of corals, the lamb-shelled brachiopods that had carpeted the seafloor for 250 million years, the last of the trilobites that had survived every earlier crisis. All of them end here. On land, the sprawling forests and the strange mammal relatives that dominated the Permian collapsed into a handful of survivors. One of those survivors has a name worth knowing. Lystrosaurus, a stocky, tusked, pig-sized animal that, in the aftermath, spread across the emptied continents almost unchallenged because so little else was left to compete with it. Michael Benton, who wrote the definitive account of this event, describes a world afterwards so hollowed out that a single dull survivor could inherit nearly all of it. And notice what recovers first and what does not. For millions of years afterward, the fossil record is dominated by opportunists and weeds, the biological equivalent of the few plants that colonize a bomb site. The specialists, the slow-growing, finely tuned reef communities that take deep time to assemble, simply do not come back for ages. The complexity that had taken hundreds of millions of years to build was deleted in a geological instant. That is what a mass extinction actually looks like on the ground. Not drama. Absence. A silence where an entire living world used to be. So, what happens to you standing on this reef? The honest answer is the shortest one in this series. Hours at best. This is not the slow suffocation of a low oxygen world where you might last days feeling wrong. It is not a hazard you can walk away from because there is nowhere on the planet the air is clean. The carbon dioxide would have your judgment inside the first 10 minutes. The heat and the thin oxygen would drop your stamina to nothing. And a strong pulse of hydrogen sulfide off that brown water could stop you where you stand faster than you could decide to run. This is the one episode where the planet is not indifferent to you. It is acutely, chemically lethal. You are not slowly leaving a place that can't sustain you. You are being killed by the air. When it was over, 96% of marine species were gone. Around 70% of land vertebrates. This is as close as animal life has ever come to ending entirely. And the oceans took 10 to 15 million years to rebuild anything like a full living womb. The engine of it all was carbon. The Siberian Traps released an immense slug of it over roughly 1 million years and triggered the worst extinction in the history of life. Daniel Rothman at MIT has spent years on a single question hidden in that sentence, not how much carbon, but how fast. Beyond a certain rate, the carbon cycle tips into catastrophe. And this is where Peter Brannon leaves the reader and where we leave you. We are putting carbon into the air roughly 10 times faster than the Siberian Traps did. The scale is not the same. Not yet. But the mechanism is identical, and the rate is the terrifying part because the Earth, as Brannon puts it, doesn't care what caused the injection. Take a breath. It still works. That is not a promise the planet is obligated to keep.